and difference of cubes, you'll be able to factor a polynomial that is the sum or difference of cubes. And of course, you can always multiply them back together to prove that the factored form is equivalent to the standard form. This is a pretty easy objective. As soon as I say it's easy, people tend to turn off and go, oh yeah, it is. I just have to memorize that, and then you forget to memorize it. Know this pattern. It will come back again and again and again. It's in this unit, and we get to polynomials. It's in that unit, and it's in the unit 9, unit 10. It just keeps coming back. So memorize. Yes, sometimes you have to memorize. The objective here is to factor a sum and difference of cubes and solve problems involving sum and difference of cubes. We're going to use SOAP. SOAP is a mnemonic. It helps us to remember what the signs are. When do we add? When do we subtract? So SOAP simply means same, opposite, always positive, or always plus. Different people will use either one. So same, opposite, always positive. And you're like, what are you talking about? Well, we need to factor some cubes. No, this is not, yes, that is ice, but we're talking about the cubes. Remember that a cube is a perfect cube plus a perfect cube. That's a sum, or a difference is a perfect cube minus a perfect cube. SOAP says same. This is the same as this. So if it's a sum of cubes, it's a plus. If it's a difference of cubes, this first thing is a minus. Then the next time we have a symbol, it's going to be the opposite. So the opposite of plus is minus. The opposite of minus is plus. And then the last one is always positive. Always, always, always positive. So what do we need then? Well, here, these are our cube roots. If you notice that you have a sum or a difference of cubes, you figure out what the cube root is. The cube root of a cubed is a, the cube root of b cubed is b. And then you connect them with the same operator. Over here, we're going to square. Let me give myself a little more room here. We're going to square, multiply, and then we're going to square again. So we're going to square the first term, a squared, then we're going to multiply the two terms, a times b, then we're going to square the last term, b squared. And the way we figure out if we're adding or subtracting is just with SOAP. So it's cube roots, SMS. Cube roots, SMS. Square, multiply, square. And what are we doing that with? With the cube roots. And we're connecting it all together with some SOAP. Now, let's look at some numbers. If we look at x cubed minus 8, yes, 8 is a perfect cube. Yes, you should know some of your perfect cubes. Okay, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. When you start going much past that, you might not recognize them right away, but you will when you start getting into this unit. Okay, so I've got x cubed minus 8. Well, the cube root of x cubed is x. The cube root of 8 is 2. So here I just got my cube roots. Now, what am I going to do with those cube roots? Well, I'm going to use a little bit of SOAP. I'm just going to, and I've got this guy going on and this guy. So S stands for same. Opposite, just that. The opposite of minus is plus, and then this is always plus. What goes here is the cube root. What goes here is the cube root. Then I'm going to square the first cube root. Then I'm going to multiply 2 times x. So I'm going to multiply them together. And then I'm going to square the last thing and get 4. So here's my square, my multiply, my square. SMS. I factored a difference of cubes. Over here I have a sum of cubes. Well, again, cube root is going to be 3x squared. Oh, how did I get x squared? Well, x squared times x squared times x squared is x to the 6th. Additionally, you take this power and divide it by 3. So 6 divided by 3, that's how I got the 2. So 3x squared, and then the cube root of 64 is 4. Now that I have my cube roots, I can put parentheses around them, and I can use same. And then out here, I'm going to have opposite and always positive. What goes here? I need to square this. So 3x squared squared is 9x to the 4th. Then I'm going to multiply these two. 3x squared times 4 is 12x squared. Then I'm going to square the 4 and get 16. So I have my same, opposite, always positive, and then over here, s, ms. Square, multiply, square. Yes, you have to memorize this pattern. Can't do anything else about it. Next up, is 8 a perfect cube? Yes, x cubed is a perfect cube, and 1 is a perfect cube. So my cube roots, 2x and 1. Now I'm going to need my same, opposite, always positive. Now I'm going to square this and get 4x squared. I'm going to multiply them and get 2x, and then I'm going to square 1 and have 1. So again, same, opposite, always positive, and then over here, s, m, s. Okay? Now we get to this one over here and we say, ooh, 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 ooh. 2 is not a perfect cube. 16, not a perfect cube. It's not a sum of cubes. Oh, but what do we do first all the time? Always look for our greatest common factor first. When I do that, I get 2x cubed plus 8. Now I've taken out my greatest common factor. Now I have a sum of cubes. I still have the 2, can't lose my greatest common factor. The cube root of x cubed is x. The cube root of 8 is 2. And then I know I'm going to have my trinomial. And then it's same, opposite, always positive. Then I have x squared. 2 times x is 2x. 2 squared is 4. I have same, opposite, always positive, and then it's squared, multiplied, squared. You do not have to put SOAP and SMS underneath your answers. This is the answer that you would put in your box. The SOAP and the SMS, that is what you're telling me so that I know you know what you're doing. Okay? In summary, we're going to keep it clean. We're going to use SOAP to factor sum and difference of cubes. Keeping it clean. Same, opposite, always positive. You get the cube roots, then you square them, multiply, square them. Okay? We can also multiply these factors back together again to prove that they get the result. And I'm going to do that once here. We're just going to do it with the difference of cubes. So if I have a and negative b, I'm going to do it in a multiplication box because it's much easier to see that way. A squared, ab, and b squared. Give myself a multiplication table. A times a squared is a cubed. A times ab is a squared b. A times b squared is a b squared. Negative b times a squared is negative a squared b. Negative b times ab is negative ab squared. Negative b times b squared is negative b cubed. Now, I've got to add everything together inside the box. So I've got an a cubed. And then I've got minus a squared b plus a squared b. That makes a big 0. Minus ab squared plus ab squared is another 0, leaving me with minus b cubed. It checks. And doing the sum results in the same proving. Okay? If I multiply a plus b times a squared minus ab plus b squared, I would get a cubed plus b cubed. That is factoring sum and difference of cubes. You must remember the pattern. Okay? Great.